Introduction to Statistics, Chapter 11, Inferences on Two Samples, Section 11.2, Inferences about two means-dependent samples. Requirements for running a hypothesis test regarding differences between two means using a matched pairs design. First, the sample is obtained by a simple random sampling or the data results from a matched pairs design experiment. The sample data are dependent, matched pairs. The differences are normally distributed with no outliers, or the sample size n is large. That means n is greater than or equal to 30. The sampled values are independent. Sample size is no more than 5% of the population size. Okay, running a hypothesis test using the classical approach. Determine an alternate hypothesis. This time, we're going to talk about the mean of the differences. We're going to take two samples, sample 1, sample 2. We're going to find their difference, and then we're going to run the hypothesis test on the difference. Okay, so in this case, the null hypothesis for a left-tailed test would be the mean of the differences is equal to 0. That means there is no difference. The alternate would be the mean difference is less than 0, which means the data from sample 1 was less than the data from sample 2, because if you take sample 1 minus sample 2, you would get a negative number. Okay. Now, right-tailed test. Again, the mean of the differences is equal to 0 for the null. Then we want to show the mean of the differences is greater than 0. What this implies is that sample 1 is greater than sample 2, because if you have a large number minus a smaller number, you get a number positive, which is greater than 0. Two-tailed test, you assume the mean difference is 0. There is no difference in the values of sample 1 and sample 2. The alternate would be there is a difference, so the mean difference is not equal to 0. So those would be your three tests using a matched pairs design. Okay, step 2, the level of significance still is there, the same, 1, 5, 10. Test statistic this time would be T naught would be D bar, which is the mean of the differences, minus 0, which would just be the mean of the differences, divided by the standard deviation of the differences. That's what S sub D means, standard deviation of the differences, divided by the square root of n, the sample size. Sketch the curve. The curve sketch would be the same that we've been using for all of our hypothesis tests. Left, right, two-tailed. Compare the test statistic with the critical value to see if the test is in the critical region. Write the conclusion. These are the same as what we've been doing all along. Now, the P approach, same idea. The null and alternate hypothesis, what we just discussed. You know, if it's a left-tailed test, there is no difference in the mean. There is no difference, so the mean of the differences equals 0. The first sample is less than the second sample. That means the mean of the differences is less than 0. Right-tailed test, mean of the differences equals 0. Mean of the difference is greater than 0, which means sample 1 is larger than sample 2. Two-tailed test, mean difference equals 0. There is no difference. Or the alternate would be the mean difference is not equal to 0, which means there is a difference. Okay, choose alpha again, compute the test statistics, same as what we did for the classical approach. Find a p-value using the table or StatCrunch, but in this case, if we use StatCrunch to run a hypothesis test, it gives you the p-value. Okay, and same test, what a left-tailed test, right-tailed test, two-tailed, p-value is equal to. Compare the test statistic, p-value with alpha. Remember, if the p-value is less than alpha, reject the null hypothesis. If the p-value is greater than alpha, fail to reject the null hypothesis. Write your conclusion, which is the same as we've been writing. Okay? Now, what about using StatCrunch to run the hypothesis test? Well, we're going to open, this time, okay, you're going to open your data in StatCrunch. Okay, so you're not going to click the question help. You will on some of the problems, but not all of them. Okay, so basically what we're going to do is load the data in. And then click Stat in the top menu, highlight T-Stats, click Paired, select the column that contains the data for sample 1, select the column that contains the data for sample 2. Click circle beside hypothesis test for mu of D equals mu1 minus mu2. Enter 0 for the difference, mean of the difference. Choose correct inequality sign, less than for left-tailed test, greater than for right-tailed test, not equal for two-tailed test. Click compute. Okay, now let's go back and let's run a sample of this. So if I go here to this problem, okay, it says assume that the differences are normally to compute parts A through D. Observations, xi, yi. You have 8 observations. Now, determine the DI, which is the difference of xi minus yi for each of the paired data. Now, look closely. It's xi minus yi. So you want xi first, yi second. So we're going to open the data in StatCrunch. So if I open the data in StatCrunch, pin it over here to the right. Okay, now, since it's paired data, I'm going to go down to T-Stats, paired. Now, select the column with the x value. So I select, because it's x minus y. So I'm going to click the x first. Then sample 2 is going to be the y, because I want x minus y. Now, since we have to find the differences, down here where it says Save Differences, click the difference, Save Differences. Okay, hypothesis test, we can leave it. It doesn't really matter, because all I'm looking for is the differences right now. Okay, so I would compute. So you notice it put the differences into your spreadsheet. So right here is your differences. That's what happened when you hit Save Differences. So the first difference is negative 3.5. Second difference then is 1.5. Negative 4.7. Negative 4.3. Negative 2.6. Negative 0.9. Negative 4.3. And negative 1.1. So you just enter the values, the differences. Check answer, we're good. Now, compute D bar and SD. Now, this is the mean of the differences, standard deviation of difference. So we go back to chapter 3. Remember how we found the mean and standard deviation for a set of data? We go up under Stat, Summary Stats, Columns. Now, which column do I want to? I want the column, the differences. And what do I want? I need the mean and I need the standard deviation. So then I click compute. So the mean turns out to be 3 decimal places, so that's negative 2.488. Check answer. We're good. And the standard deviation to 3 decimal places, if I look over here, standard deviation is 2.166. And we're good. Okay. Now, what are the correct null and alternate hypotheses? So what were we trying to do? Oh, C. It says test that mu of D is less than 0 at the alpha equals 0.5 level of significance. So we always start off, remember the null is there is no difference, mu of D equals 0. So if I look at this null says less than, so that's out. This says that's out. Says equal, so that's in. This says, so that's out. So it turns out that you have to use B because it's the only one that has the null hypothesis with the mu of D equals 0. And if you look at the alternate, the difference is less than 0, which was given up here in the problem. Okay, so that would be that. Okay, so now we want to run the test. So I go back over here, I can run stats. Now there's two ways to do this. I can do the t-stats with the paired and choose my columns, X and Y. Hypothesis test, we let the difference be 0, and I want to choose what? Less than, right? Choose less than. I click compute, and the p-value is 0.007. Now let me show you something else here, because we will use this on the next problem. Okay, let's say you had the differences. We have the mean and we have the standard deviation of the differences, right? So I could have went just t-stats one sample with summary. In other words, the sample would have been the differences. So the sample mean would have been that negative 2.488. The sample standard deviation would have been 2.166. The sample size, if you recall, we can look up here too, you had 8 samples. So 8 would be the sample size. And we wanted to do less than, hypothesis test. If I compute, you look at the p-value. It's exactly the same information. So you can run the test on the pairs, X and Y, or you can run it just on the differences if you know the mean and standard deviation. Okay? All right. Now, so what else do they want in this problem? So I click check answer. Okay. Now, choose the correct conclusion. You know, well, the p-value was 0.007. What was my alpha? My alpha was 0.05. So 0.007 is less than 0.05. So it's less than, so that means we're going to reject. So we have to look at the to reject. Okay? And if you reject, that means there is enough evidence. Okay? Or is sufficient evidence. Okay? So this says is sufficient. This says is insufficient. So we want the sufficient. B. Compute a 95% interval about the population mean. Okay, mu of D. Well, we haven't done this yet, but we would go through it. So you would go under stat. You could do t-stat paired. Choose the X values. Choose the Y values. Okay, this time click confidence interval, and what I want, 95%, which is what I have. Compute. Now I have my lower limit, upper limit. So the lower limit to 2 decimal places is negative 4.30, negative. And the upper bound to 2 decimal places is negative 0.68. Okay, and that takes care of that question. Okay? And like I said, let me go to the next question, 4. Here's a question, okay? And if I read the question, you know, 15 babies were asked to watch a climber attempt to ascend a hill. Okay, I'll just let you read the question here for a second. This is problem number 4 in your homework for 11.2. Now, all right, we don't have the data. We don't have all 15 results. What we do have is we do have the mean and the standard deviation of the differences. Since I have the mean and the standard deviation of the differences, I can use those and just run a 1 sample test on the differences. Now down here it says state the null and alternate hypothesis, determine if babies tend to look at the hinderer toy longer than the helper toy. Well, the difference is hinderer minus helper. So if I want to determine, look at the hinderer toy longer, so that means I want the time on the hinderer to be larger than the time on the helper. So if the hinderer is larger than the helper, hinder minus helper is going to be greater than 0, right? So I'm going to assume that it equals 0, and then I want to show greater than. So it looks like here. So I want to assume the difference is equal to 0. I want to show that it's greater because I want to show the hinderer is greater than the helper. Back here, the hinderer took longer than the helper. Now the next thing, assuming the differences are normally no outliers, test if the differences in the amount of time the baby will watch the hinderer toy versus the helper toy is greater than 0 at the 5% level of significance. Well, let me shrink this back down, pin it to the left. Let me close this. Now let me open up StatCrunch because I don't have data. Move it out, pin it to the right. Now, so I'm going to run a t-test one sample with summary. What's the mean? Well, up here in the problem, it told me the mean was 1.27. It told me the standard deviation was 1.51. The sample size, up here at the very beginning, it was 15 babies. So sample size is 15. I'm running a hypothesis test, so I assume there is no difference. So I assume mu equals 0, and I'm trying to show what? Greater than. So if I compute, I have this. And what was my question? The test statistic. Well, the test statistic, if you remember, is the t-stat. To 2 decimal places, so it's 3.26. Now the p-value, well, we go over here, p-value is 0.029. So it's 0.00, and I wanted 3 decimal places, so it's 3. Okay. Now, do we reject or fail to reject? Well, the p-value is less than the 5% level of significance, right? 0.003 is less than 0.05. So since it's less, we're going to reject. So it's got to be one of these two. And if we reject, it means there is sufficient evidence. So is, this says there is not sufficient evidence. This says there is sufficient evidence. So we want is. Okay. What do you think the results of the experiment imply about babies' ability to assess surprising behavior? Okay, well, there was sufficient evidence, right, that one was longer, so there is sufficient evidence. So it looks like, you know, A or D. Let's see. There is sufficient evidence that babies have the ability to assess surprising behavior. There is sufficient evidence but do not have the ability. Well, we were trying to show they do have. So there we go. Okay. Next question. All right, let me go back here to the PowerPoint. Constructing a confidence interval. We just did that. Okay, the confidence interval will be d bar minus e, d bar plus e, where d bar is the mean of the differences. And E is going to be your critical t-value times the standard deviation of the differences divided by the square root of the number of matched pairs. Okay, the interval is exact when the population is normally distributed and approximately correct for non-normal population provided that the sample size is large and is greater than or equal to 30. Lower bound will be d bar minus E. Upper bound would be d bar plus e. And of course you could write that d bar minus the critical t-value times the standard deviation of the difference divided by the square root of n, and plus that. Either way, they can be written either way. Using StatCrunch, we just went through that. Okay, you click, you'll pick the two, and you go down through and compute. We already went through that on StatCrunch, so I don't think I need to read down through every one. Now, using confidence interval to determine the outcomes for a two-tailed hypothesis test. Same thing we've been doing. Okay, if it's two-tailed, the mean difference equals 0 versus the mean difference not equal to 0. So, if the confidence interval contains 0, if 0 is in the interval, do not reject the null hypothesis. If 0 is not in the interval does not contain 0, reject the null hypothesis and conclude there is a difference. And this brings us to the end of 11.2.